So my name is Sarah. I'll be the moderator, meeting moderator tonight, and this webinar is recorded, and the YouTube link will be available on our chapter website. And first, let me quickly go through the past community news. And PASS has many virtual chapters. For those of you who don't know, PASS membership is completely free. This is our virtual chapter, and we would like to invite you to join us. And once you join, you can get the meeting information automatically through your email. We also have another session in February, so you're welcome to join us. And this, we also have a WeChat group, and this is the code. If you would like to join, you're more than welcome to join. Sorry, for some reason my computer doesn't. Okay. Well, majority of these meetings are over at this point. I guess only the last one. There are some SQL Saturday events, which is great. It's like a mini session of PASS Summit. So I would encourage you guys to check it out. And like I said, you can also join a local chapter, enjoy the, benefits specifically for local chapter members. So tonight the topic is called Hardware 201, Selecting and Sizing Database Hardware for OLTP Performance. Our speaker is Glenn Berry. He works as a principal consultant at SQL Scale. He's a SQL Server MVP and has a lot of certifications. Also, his expertise include DMVs and high availability, hardware selection, and storage subsystems. Glenn is also an adjunct professor at University College, University of Denver. Maybe his students also like to take tests. Okay. Without further ado, I'll turn the screen to Glenn. Give me a second. Oh, my computer tonight just doesn't want to cooperate. So, okay.
Okay, great. Can you see my screen?
Yes.
All right, well, thanks a lot for that introduction. Let me get PowerPoint going here. So this is Hardware 201, Selecting Database Hardware. And I'm Glenn Berry. I work for SQL Skills. There's my email right there, glenn@sqlskills.com. If you have any questions that don't get answered during the session, feel free to send me an email and I'll definitely answer it for you. So a little bit about me. I've been a SQL Server MVP since July of 2007. I've written several books and I'm pretty active on Twitter and I write a lot of blog posts, especially about hardware. And Twitter is a really good way to get to know people in the SQL Server community, so I encourage you to give it a try, and if you haven't done that already. And there's a little bit of marketing about SQL Skills. We're a consulting company, and we do online training and in-person training, and we develop courses for Pluralsight. And that's one thing I want to point out in the next slide is if you want a free 30-day pass to Pluralsight, just send an email to my boss, paul@sqlskills.com, with the subject line user group, and he'll send you a code that'll let you use Pluralsight for 30 days. and there's no credit card required. They're not going to bug you. And so if you want to try to listen to some of these courses, you can do it for free if you do this. And Paul's on vacation now out scuba diving in the Pacific, so send him some email and make him do some work when he gets back. So anyways, why does database hardware matter? Why do we care about this? Because a lot of DBAs, they don't care about hardware. You know, they're more interested in writing queries and making sure their database backups are running. But database servers are actually mission-critical assets for your organization. And anytime there's any kind of performance or scalability problem, people tend to notice really quickly. Quite often you've got multiple applications that depend on that database server. And if the hardware is not chosen properly, it's really hard to compensate for that. It's really common to see really inadequate I/O performance capacity that completely cripples your system. A lot of times I see database servers who don't have enough memory, which is kind of ridiculous since memory is so inexpensive nowadays. And then sometimes you see cases where you don't have enough CPU capacity to support your workload. And choosing your hardware selection wisely can save you so much money on your hardware and on your license costs that you can basically get your hardware for free. And it's really important that you pay attention to the details when you pick a particular processor for SQL Server, and that's what a lot of tonight's going to be talking about. And in many cases, you can take a 2-socket server and replace an older 4-socket server, or a 4-socket server can replace an older 8-socket server because the processors have gotten that much faster in the last several years. And again, this is something you need to pay attention to, and don't just let somebody in your IT department pick your database server hardware for you. So the top scalability issues you run into with SQL Server, because I don't want people to think that I'm saying that hardware will solve all your problems. So the thing that's going to cause the most problems for your performance and scalability is poor application architecture and design. That'll kill the best hardware. And then poor database architecture and design is another big problem you run into. And quite often those first two things are out of your control as a DBA. But the next one, poor indexing strategy and maintenance, a lot of times you have a lot more control over that as a DBA, and you can find key missing indexes and make sure your indexes are well maintained and have a very nice effect on your performance. Another thing you definitely have control over as a DBA is your instance configuration settings. And if you just go and do a default installation with all the default settings, you have a lot of issues that you need to correct, and those are pretty easy to fix. Same way with database property settings. A lot of times those are wrong out of the box, and you want to go in and change some of those. And then it's really common to have just a totally inadequate storage subsystem for your workload. And then also what we're going to talk about mostly tonight is just having old or inappropriate hardware for your workload. And I've got a complete Pluralsight course that talks about scaling SQL Server that you might want to listen to, especially with that free code. But again, the key point is that hardware cannot solve all your problems. You have to take care of these other things also. So this is your nightmare. If you're a production DBA, you don't want to see Windows Task Manager looking like this with all of your processor cores pegged for a sustained period, because unlike a web server, you can't just take it out of the server farm and reboot it. If it's the database server and you're stuck like this, that's a really bad place to be. And this is another even bigger box, 120 cores pegged at 100% CPU. And if you pick the right hardware, hopefully you'll have less chance of this ever happening to you. So scaling up SQL Server. Scaling up means you go from, say, a 2-socket machine to a 4-socket machine to an 8-socket machine, and you do that as the smaller machines become saturated with so much work. And that's really easy from an engineering perspective. You don't have to do a whole lot of development or testing to do that. And sometimes it's called a forklift upgrade. But the problem is, as you go from a 2-socket to a 4-socket to an 8-socket server, the cost goes up in an exponential manner. So it doesn't just double every time you double the size of the server. The cost of the hardware goes up really quickly, and then your SQL Server license costs start to get really expensive. And then finally, even if cost is not really an issue as you're doing this, you're going to run into hardware license limits that cause problems. So right now, the limit with Windows is 640 logical processors, and no commodity hardware that you can buy right now will run into that limit, so that's not really an issue. But the real issue is 4 terabytes of RAM, That's a license limit in Windows Server 2012 R2, and you can get 6 terabytes of RAM in a 4-socket machine right now with 64 gigabyte DIMMs. So a common 4-socket machine exceeds the license limit that Windows allows you to have. And luckily, they're going to raise that limit in Windows Server 2016 to 12 terabytes of RAM. So we won't be butting into that just with commodity level servers. So just be aware that you can scale up, but at some point you're going to reach the end of the line and get the biggest box you can possibly get that runs Windows, and then what do? So SQL Server and hardware selection, nobody in my career has ever come to me and said, oh, your database server is too fast. You know, they'll complain all day about how slow the application is, and of course the database server is always guilty until proven innocent. You know, if you don't know this, DBA really stands for default blame acceptor. And the point of this is that you don't want to be needlessly frugal with your database server hardware. You know, a lot of times when you're in IT, you're trained to save money anywhere you can. And if it's a web server or a file server, yeah, you can save a few $100s by going with a less expensive processor, for example, or less memory. But that's a huge mistake with a mission-critical database server, because you're paying a huge amount of money for your SQL Server licenses, and the hardware cost compared to that is a very small portion of your overall cost. You know, hardware is really affordable compared to SQL Server licenses. And on that note, don't ever let anybody talk you into reusing old database hardware when you upgrade to a new version of SQL Server. That's a huge mistake, and it encourages you to upgrade in place, which is much more risky than upgrading your entire platform and having lots of time to test everything before you do your production cutover to the new hardware. And as you're doing this and looking at hardware, be aware of the SQL Server hardware licensing limits. You know, you have Windows license limits and also SQL Server license limits. And this comes into play especially with SQL Server Standard Edition. So SQL Server Standard Edition starting in 2008 R2 had a 64 gigabyte RAM limit per instance, and they left that at the same level for SQL Server 2012 Standard Edition. And that's a big surprise for a lot of people. I've got a desktop upstairs that has 64 gigs of RAM in it. It's kind of ridiculous that a database server is limited to that much RAM for how much SQL Server can actually use. Now they raised that a little bit to 128 gigs in SQL Server 2014 Standard Edition, but that's still ridiculously low. And again, this is per instance, so you could sort of get around that by installing multiple instances of SQL Server on a really big box, but that's sort of a nightmare to manage. So what they're going to do for SQL Server 2016 is they're going to raise that limit again, but they haven't said how much. So just be aware of that if you're looking at a server and you know you're going to be stuck running Standard Edition instead of Enterprise Edition. The other thing you got to be aware of is that there's a 4-socket or 16-core, physical core, limit for Standard Edition in all of the versions of SQL Server that have come out since 2008 R2. And that's caught a lot of my customers by surprise. They go out and buy a nice new server with, say, 32 physical cores or 64 physical cores, and they find out they can only use 16 of them. And SQL Server doesn't even spread it across the processors evenly by default. And I've run into a lot of customers that that's happened to them and they didn't realize it. So just be aware of that if you're stuck with Standard Edition. Now, if you can use Enterprise Edition, you can use whatever the operating system limit is for RAM and processor cores and sockets, so you don't have to worry about this as much. Now, there's 2 different server architectures that are out there. The first one is symmetrical multiprocessing, or SMP, and that's an older architecture that's really not around for any new servers anymore, but it used a single shared system bus that was shared from all the processors to get out to memory, and became a major scalability bottleneck as you added more and more sockets. So once you got above 4 sockets, it really hurt your performance and scalability. And this hasn't been the case since about 2008 on the Intel side, and AMD's had support for NUMA even before that. But if you've got some really older servers that are around, you're probably still dealing with SMP, which is really bad. Now the newer architecture is non-uniform memory access, or NUMA, and that divides your memory into separate NUMA nodes, so each processor has its own NUMA node that it has really fast direct access to, so it can talk to the memory really quickly. And you can also talk to the other NUMA nodes with foreign memory access, and that's a lot slower. And all modern Intel and AMD processors have NUMA support, and that's what you want. It's really important, especially with 4 and 8 socket servers. Now, sockets and cores explained. A lot of DBAs sometimes get confused about what's the difference between a socket and a core and a physical core and a logical core. So a processor socket holds a single physical processor, and you have typically 1 socket, 2 socket, 4 socket, and 8 socket machines. And back in the good old days of SQL Server 2008 R2, that's how your licensing was done. So you would get 1 processor license that covered that entire processor, no matter how many cores were on it. And then when SQL Server 2012 came out, they changed the licensing so it was based on physical cores instead of physical sockets. And so a modern physical processor has multiple physical cores inside, and typically it's anywhere from 4 physical cores all the way up to 18 right now. And so you've got to get a processor license, a core license for each one of those physical cores. And that's how it works with SQL Server 2012 and newer. And those licenses are pretty expensive. We'll talk more about that later. And then if you have Intel processors, that physical core can be divided into 2 logical cores with Intel hyperthreading. And those cores don't count for physical servers for licensing, but they do count for virtualized servers unless you have enough core licenses for the entire host and you have Microsoft Software Assurance. So we'll talk a little bit more about that later, but just be aware of how that works. And having the logical cores gives you a little bit more capacity, about 20 to 30% more capacity, but it doesn't actually improve the performance of your cores. So that's what hyperthreading is about, and we'll talk more about that in a few slides. So database server specific hardware factors. Again, make sure you've got NUMA support, which all new servers will have. That gets rid of that front side bus contention and gives you much better scalability. It's also important that you've got the largest possible L2 and L3 processor cache sizes on whatever processor you actually pick. That's really important for database server performance. And then finally, you want to make sure you've got the highest single-threaded processor performance possible, because most OLTP queries are really short duration, only a few milliseconds in most cases, and they only run on a single thread. So if you don't have a big storage bottleneck or memory bottleneck, then your processor performance is your ultimate bottleneck, and having a faster single-threaded processor will just make your queries run that much faster. It's just as simple as that. And you're going to pay the same price for your core license whether you have a slow processor or a really fast processor. So you might as well get a fast processor and get the most bang for the buck there. So Intel specific considerations you need to worry about. Hyperthreading was that feature that I mentioned earlier, and this came out way back in 2002. And when it first came out, it got kind of a bad rap in the SQL Server community because it was using the old Pentium 4 version of the Xeon processor. It was called the NetBurst architecture, and that processor had a really deep processor pipeline, and what it meant is that if it had a cache miss, it was really, really expensive. So as it switched from one logical core to another, it would have cache misses and have to reload the caches from main memory. And that slowed it down a lot. So you'll see a lot of old white papers and blog posts saying, oh, you should turn off hyperthreading for SQL Server. And that was sometimes true, but not always back in 2002. But nowadays it's not true because we have much newer processors that don't have that huge cost when you have a cache miss, and they have faster main memory anyway. So hyperthreading works a lot better, and it usually improves capacity significantly when you have it turned on, especially with single-threaded OLTP workloads. So it's a good idea to turn it on, in my opinion. The only time you might want to turn it off is if you're running a virtualization host and you want to make sure that all your virtual CPUs are true physical cores. And if you have a really strict data warehouse kind of a workload, where most of your queries are getting highly parallelized, in some cases hyperthreading will hurt there, but you really should test it before you just turn it off. So the other feature that's important, especially for Intel, is something called Turbo Boost. And this is not like the old turbo button that maybe your grandpa had on his computer back in the 1980s. This is similar, but it's different. And what it does is when individual cores are not working that hard, other cores can have their clock speed boosted temporarily. And that's just the way it works, and it's built into the processor, and you can control it in the BIOS of the machine. And having this turned on is very helpful for your OLTP performance because it boosts the clock speed by 20–30% in some cases, and that just makes your query run faster. And there's no reason not to have it turned on. Modern servers have plenty of excess cooling capacity, and it's not going to make your server overheat. So just make sure that it's enabled in the BIOS. There's really no downside to it. All right, general processor considerations. If you have the budget, I always try to do what I call over-provision my processors. I want to get the very best single-threaded performance I can get for my OLTP workload. If I want to have more capacity and scalability, then I'll go with a higher core count processor, but higher core counts mean lower single-threaded performance, so it's sort of a trade-off there. You can get better performance and less capacity, or more capacity and less performance, and we'll talk about how you decide that a little bit later. But having what some people might call excess CPU capacity can help you reduce your I/O requirements. So that excess CPU capacity can be used to do things like data compression and backup compression. So the processors are compressing data and taking the load off your I/O subsystem and moving it to your processors, which usually have extra headroom. And processors are pretty inexpensive compared to the rest of the machine and your SQL Server license costs. And adding I/O capacity with an enterprise SAN is really expensive. So if you can get around that by having the best CPU and then data compression, for example, that might be a huge win. And one mistake I see a lot of people do, especially IT people who don't know anything about SQL Server, is that they'll go and look at, say, the Dell website to spec out a new server, and they'll see 40 or 50 different processors they can choose from for a certain model server, and there'll be maybe 3 or 4 processors that all have, say, 8 cores, and they'll pick the least expensive one or the one in the middle to save a few $100s. And that's a huge mistake with SQL Server because you're paying a huge amount for your licenses, so you want to pick the fastest one at a given core count. And that's just the way you want to do it when you're looking for SQL Server rather than a file server or a web server. All right, general memory considerations. You want to try to put as much memory as you can in the machine within the SQL Server license limits, because having a larger buffer pool cache means that you're finding the data you're looking for in memory in the SQL Server buffer pool rather than reading it from the disk subsystem every time. And that's orders of magnitude faster to find it in memory than having to go out to disk. And having more data in the buffer pool and not being under memory pressure means that you're not going to have to be doing lazy writes and checkpoints as often. And RAM, actual physical RAM, is much, much faster than any disk subsystem. Even the very best flash storage you can get is not anywhere near as fast as actual physical RAM. And what you want to try to do, and it's not that hard to do nowadays, is try to fit your entire database into memory in the buffer pool. That's the ideal situation. You know, and I run into so many people, they go out and buy a new database server and they put 32 gigs of RAM in it or 64 gigs of RAM, and the thing holds 768 gigs of RAM. And you know, unless you're just severely budget constrained, the more RAM the better. You know, there's really no downside to having lots and lots of RAM. I mean, the only slight downside is that it'll make your server take longer to boot because of the memory checks, but you can disable that in the BIOS, and then it'll use more electric power. But beyond that, having RAM is a really, really good thing. And if you are stuck with SQL Server Standard Edition, there's a new feature they added in SQL Server 2014 called Buffer Pool Extensions. And that lets you set aside some space in your file system, hopefully on local flash storage, for a caching file that caches clean buffer pool pages. And with certain kinds of workloads and certain kind of storage subsystems, that can help your performance. And it's only really interesting with standard edition. If you have enterprise edition, you're better off just to put more memory in the machine until the machine is full. But with standard edition and that low memory limit, BPE can be a useful feature. All right, SQL Server 2014 licensing considerations. Enterprise edition is licensed per physical core, and you have to pay a 4-core minimum per physical socket. So even if you had a really old machine that only had 1 or 2 physical cores, you would still have to pay for 4-core licenses. So that would be really dumb to do that, and that would be another reason to finally retire that really ancient hardware that had less than 4 cores. And if your licensing costs are your biggest issue, what you can do, and it's actually a really good idea, even if licensing costs are not a big issue, is to, excuse me, to get what's called a frequency optimized processor. So it has fewer cores, but it has a higher clock speed. And so you get better performance and your licensing costs are reduced. Now, if you're worried about how much of a load you can handle, increasing your capacity and scalability, then you might go for a higher core count processor, and that's going to cost a lot more for your licensing, and then your performance is actually going to be less because the clock speed is lower. So as you're doing all this, pay attention to the processor architecture and the cache sizes, not just the clock speed. Don't be like my mom, who might go into Best Buy and just pick a processor based only on the clock speed. There's a lot more to it than that. And we'll get into that a little bit in the next few slides. So here's how much it costs for a SQL Server license. I keep saying how expensive it is. Well, standard edition, you can get a server license and then pay for CALs for each person who has to connect to it, or you can get a core license, and again, you've got to get one of these for each one of the physical cores and each one of your processors. And then Enterprise Edition only lets you do it with core licenses. So they're about $6,900 per core license. So it's really easy to spend 10 times as much on the licenses as the hardware costs if you're not careful. So just be aware of that as you're going out and speccing out a server, how much those licenses are going to be for SQL Server. So traditionally, people have gone out a lot of times and just gotten a 4-socket server for a database server, because 5, 6, 7 years ago, 2-socket servers just didn't have enough memory capacity or enough processor horsepower to run a typical database server workload, and they didn't have enough expansion slots for things like HBAs and RAID controllers and things like that. But that's changed, and so over the last several years, 2-socket servers have gotten really powerful, and they can handle a very high percentage of the workload you're going to run into. And the other thing that's important about this is that the way Intel releases new processors, they release the latest and greatest processor in the mobile space and for laptops first. And then usually within a few months, they release that same generation processor for desktop processors. And then it comes out for 1-socket servers pretty quickly. And then there might be a slight delay when it comes out for 2-socket servers. But then a lot of times there's a huge delay, like 12 to 18 months, before that generation processor comes out in the 4-socket space. So depending on where Intel is in their release cycle, if you get a 2-socket server, it's like buying this year's model car instead of one from 2 or 3 years ago. And that's a huge difference, and that's something to pay attention to. And so right now, Intel has Haswell out for the 2-socket and the 4-socket space, and they're pretty equal. There's not a huge difference. But in about a month or so, they're going to release something called Broadwell in the 2-socket space that's going to open up that gap again. So that's something to pay attention to. And then 2-socket servers can have up to 768 gigs of RAM, which is more than enough for many people's workloads. And also, up until recently, only 2-socket servers had the latest version of PCIe, PCIe 3.0, and 4-socket servers didn't have that. But over the last about a year and a half, roughly, that's been available in 4-socket servers. So my point is that even now, with the performance being roughly equal, you can still run a lot of times your workload on a 2-socket server instead of a 4-socket server. Now, why would you get a 4-socket server then? Well, tradition. People just did it a lot in the past. But And there's some cases where 4-socket servers are just still necessary because they do have more physical and logical cores, which gives you higher CPU capacity, and they also have more memory capacity. I mean, if you really do need more than 768 gigs of RAM, you can get up to 6 terabytes of RAM in a 4-socket server. So some people really do need that much memory, but it's really not that common. And then you can get a few more PCIe slots. You can get 10 instead of, say, 7 in a 4-socket server versus a 2-socket server. So that's the main reason you might have to go to a bigger machine. But I try to avoid that as much as possible. I really like 2-socket servers for most workloads. And here's an example of what I'm talking about. This little comparison here I did just a few days ago. I updated it. And this takes one 4-socket server compared to two 2-socket servers, okay? And the one on the top is a Dell PowerEdge R930, and it has 4 processors that have 18 cores each, and it has 3 terabytes of RAM in it. And here's what its estimated TPCE score is. This is an OLTP benchmark that tells you how much capacity this machine has from a processor perspective primarily. So 4290 is its score, okay? And if you divide that by the number of logical cores in the machine, 80 of them, you get this figure right here, 53.62. So that's an indication of the single-threaded performance of that processor in that machine. And this machine with that much memory would be about $85,000. And then you would pay about $275,000 for the SQL Server licenses. So here's your total cost for one 4-socket server. And down here is 2 2-socket servers. These are Dell PowerEdge R730s. And so the 2 of these together have 4 of these processors, and they're only 8-core processors instead of, this is actually 10-core processor, not 18. But anyways, 1.5 terabytes of RAM between the 2 of them. They've got 14 PCIe slots instead of only 10. And then the score of these 2 together would be this much, which is slightly higher than this. It's about 10% higher, so 10% more capacity. And then the logical core score per core is 72, so that's about 50% higher single-threaded performance. And then look at the hardware cost. It's less than half for both of these together, and the license cost is also lower. So overall, you save over $100,000 to get 10% more capacity and 50% better single-threaded performance. Now, of course, this assumes that you can split your workload between 2 servers, which not everybody can do, but sometimes you can. So it's something to think about. Don't just go in the default, oh, I need a 4-socket server, and get a bigger, slower machine when 2 faster machines would be cheaper and give you better performance than that one big machine. All right, Intel or AMD processors. You know, the answer is Intel, and it's been the case for about 7-8 years now. And I hate to say that because I wish AMD could compete with Intel at the high end, but they just can't. Their single-thread performance is not even close to Intel on all the benchmark tests. And unfortunately, to make things even worse, since AMD tends to have really high core count processors, they're more expensive to license for SQL Server, and you get less performance and they cost more to license. And it's so bad that Microsoft has this thing called the core factor table that gives a 25% license discount if you use AMD processors. But even with that discount, it still costs more to license an AMD-based server. So that's going to be a pretty hard sell to my boss. So let's go out and spend more money and get less performance. So AMD is just a bad choice if you care about performance. Now, if you are really, really budget constrained and getting the least expensive hardware possible as your main goal in life, then you can run on AMD. Just be aware that you're not going to get nearly the performance that you would have gotten with an Intel processor. So going on, this is something that you need to understand if you're going to go out and pick a processor. Intel has this thing called the Tick Tock release strategy. And this has been going on for about over 10 years now. And what it means is that every 2 years, blue is a microarchitecture and orange is a manufacturing process technology. So every 2 years, they release a whole new microarchitecture with a code name like Nehalem or Sandy Bridge or Haswell. And that's a whole new processor design. And then a year after that, they take that same architecture and shrink it from 45 nanometers in this case to 32 nanometers, and that's called a tick. So this is a tock, and that's a tick, and that's a tock, and this is a tick. And they do that on a schedule. And so you can look at a processor model number and understand how old it is and how far behind it might be the latest and greatest. That's one reason this is useful. But the more important reason this is useful is that this gives you their schedule going on into the future. So you can look at what Intel is doing, and you can look at what Microsoft is doing with Windows and with SQL Server. So for example, later this quarter, they're going to release the Broadwell in the server space. And then sometime later this year, Windows Server 2016 and SQL Server 2016 are going to be released. So at some point in 2016, the stars are going to kind of align, and you'll have a new processor available that'll go in a new server, and then you'll have a new version of Windows and a new version of SQL Server. So knowing that as an architect, you can say, okay, we're going to plan on upgrading sometime in the middle or last part of 2016. We're going to go out and get a new database server with a new version of the OS and a new version of SQL Server, and you start lobbying for that and putting your plan together for how you're going to make that happen. So this helps you do your planning. And this chart right here kind of explains, as I call this the Intel processor family tree. And so these darker bands are the tocks, and the lighter bands are the ticks. And this shows you the year that it came out roughly, and then how the process was shrinking. And then here's the model numbers and the code names. And so where we're at right now is right here, Haswell EP, which is for 2-socket servers, and Haswell EX for 4-socket servers. And that's the latest and greatest that you can get in the 2-socket and 4-socket space. But sometime later this quarter, Broadwell EP will come out. It'll be the E5 2600 V4, and that's going to open up a little bit of a performance gap over Haswell EX. And then Broadwell EX won't come out until very late this year and maybe early 2017 probably. So that gap will open up for most of this year, and 2-socket servers will be faster than 4-socket servers. And you can look at this and see what's happening in the future as far as we know right now. So, and another thing this is useful for is if you go and look at the model of processor that's in your current server and you find out that it's way back here, you can say, hey, wait a minute, this thing is ancient and it's really, really slow compared to a modern server, and perhaps it's slower than my laptop. And I'm not kidding when I say that. If you go back this far, your 2-socket or 4-socket database server might actually have less CPU capacity than your laptop, and that's not an exaggeration. So the current Intel server processor families that are available right now, well, for single-socket servers, they have something called the Xeon E3 family, and it's up to V5, and that just came out about a month ago. It's called Skylake and uses a 14 nanometer process, and that's basically a server version of a desktop CPU that's in single socket servers. And then in the 2-socket space, they've got the E5 V3 family, and they've got different variations of that. And the one you want to use is right here, the E5 2600 V3 Haswell EP. And the one you don't want to use is this one, the E5 2400 V2. This is sort of a economy version of this that has lower clock speeds and doesn't perform nearly as well. And Microsoft doesn't care. They'll charge you the same cost if you buy this one versus this one. So, and only certain server models will have this one versus this one, so you need to pay attention to that. And then if you need to have a bigger server, you want to be on E7, which is for 4-socket and larger, and they're up to V3, which is Haswell EX. The EX means expandable, and it's for larger servers. All right, so the very current top-of-the-line Haswell EP, again, is this E5 2600 V3, and it was a TOC release that came out in the 3rd quarter of 2014, so it's been around a little over a year now. And it goes up to 18 cores, and it's got PCIe 3.0 support, And here's the top of the line model. It has 18 cores with all its speeds and feeds. And the important thing to know about this is the clock speed is pretty slow when you have an 18-core processor. And that's not good for SQL Server. So let me show you this next chart. This is super important here. This is probably the most important slide in the entire deck. But this is a list of what I say are preferred processors from this family. And the way you read this, here's the model numbers. And then this first number here, 4, 6, 8, 10, that's how many cores that this processor model has. And there's about, I don't know, about 45 processors in this entire family, but these are the best ones that are on this chart for SQL Server. So if you decide, well, we can only afford 4 cores, then you want this one. But if you need to go up to 6, you want this one. If you need to go to 8, you want this one, and so on. And what you might notice here is the 4-core processor has a base clock speed of 3.5 gigahertz, which is really fast, whereas the 18-core is only 2.3 gigahertz. And that's a pretty significant difference. And then you'll notice over here, this is something called the turbo speed. So when Turbo Boost kicks in on an individual core, you can go from 3.5 to 3.7. There's not a whole lot of difference here, but there's a huge difference up here. But the problem is you don't get this full turbo speed unless a system is relatively idle. So on a busy database server, you're going to spend most of your time here, not here. So that's why these ones on the bottom of the chart are faster. Excuse me, but they're a lot faster for single-threaded performance, but they have a lot less capacity. So it's a trade-off between performance and capacity. And then the other reason you want to be down here is that, remember, you're paying $6,900 for each one of these cores. So as you go from here all the way up to here, the money adds up really fast. So rather than letting, Shannon, your IT person, pick your database server, and she picks an 18-core, well, you want to be the smart DBA and pick the 8-core maybe that's so much faster. And then you save so much money on your license costs that your database hardware is completely free. All right, so here's another chart that shows, the family history of the E7 line going back way back to about 2005, and the different code letters. And where we're at right now is Haswell EX, and then sometime later in 2016 or early 2017 they're going to go to Broadwell EX. But Tick Tock, Tick Tock. And this is just important to know these code words and what they mean. All right, so the next thing is Haswell EX, and that came out in May of 2015, and it has 18 cores also, up to 18 cores, and PCIe 3.0 support. And again, you have some choices there on which one you get, but not as many choices. And these things are a lot more expensive than the E5s too. So here's a similar chart, and there's fewer choices here. So you've got a 4-core model, and then you jump up to 10, and then 16 and 18. And so that's another reason why I like 2-socket servers better, more choices on your processors. And then look how expensive these guys are. They're about 2 to 3 times more expensive than the E5 processors, and they're not really that much different. They have a few what are called RAS features for reliability, but that doesn't matter in real life that much, to be perfectly honest, and there's definitely not worth that much more money. So to cut to the chase here on processor selection, if you know that you're going to have a single socket server for a pretty small database server workload, and it's going to be an OLTP workload, a 1-socket server, this is the processor you want right now, the E3-1280 V5. It's a 14-nanometer Skylake, and here's the clock speed, how big the L3 cache is. It's only got 4 cores. It's basically a server version of a desktop processor, and it can only do 32 gigs of memory in the machine. So it's essentially a desktop in a single socket server, but it gives you really, really fast single-threaded performance, but you do have a low core count and less memory. So a small OLTP workload would run really well on this. Now, if you know that you needed to have a small data warehouse or a reporting workload running on a single socket server, which is probably not that common, but if you were in that situation, then you'd want to get this one instead. This is an E5 2470, and it has 10 cores instead of 4 cores, but they run a lot slower, 2.4 gigahertz instead of 3.7, and this will have up to 96 gigabytes of memory instead of 32 gigs. So this is like a big delivery truck compared to a Tesla. And that's the difference we're talking about here. All right, this is in the 2-socket space. A 2-socket server for an OLTP workload, this is a really good choice. This is that 8-core version of the Haswell EP with a really fast clock speed and up to 760 gigs of RAM. And if you knew you needed to have more of a data warehouse reporting kind of a workload, you want to have more cores. So here's the 18-core version, the 2699 V3, and again, see the clock speed is a lot slower than on this. So this is the big delivery truck versus the Tesla here. And then in a 4-socket server, OLTP workload, you want to have fewer cores and a higher clock speed versus a data warehouse reporting workload, more cores, and then you pay the cost of a lower clock speed. And of course, you have to pay more license costs when you have more cores. And then finally, if you need to have an 8-socket server, your only real choice is this guy. And then this is one you don't want to use. And the reason I say this thing's not sold anymore, but a lot of people still have these around. And if you let somebody like your boss talk you into reusing an existing server, you might have one of these, unfortunately. And this is a really, really bad choice. This was the last generation Intel processor that didn't have NUMA support. It was SMP. And so this thing had a pretty low clock speed. This is from like 2009. And it has 6 cores, but no hyperthreading and no turbo boost. And you can only have 256 gigs of RAM in a 4-socket server. So that's really low by modern standards. So if you had one of these laying around and your boss said, well, we paid 40 grand for that thing and it's still under warranty, let's reuse it for SQL Server 2012 or 2014, that would be a huge mistake because you have to buy 24 licenses and then you're only getting 1/3 of the performance of a modern 2-socket system. And that would just be a dumb thing to do, and I saw a lot of people doing that. So don't make a mistake like that. Always insist as much as you can that you need a new server. Don't reuse one from even a couple years ago. All right, so just here's an indication of the prices of these different processors. AMD is very inexpensive compared to some of these. And so you want to kind of be in this middle if possible. The 2-socket server with an Intel E5 processor. Those are not super expensive and they give you the best performance. So here's how much memory costs. And I just updated this a couple days ago and I was really surprised and happy that 32 gig memory modules are actually less expensive per gigabyte compared to 16 gigs. And that's never been the case before. So now it finally makes economic sense to get 32 gig modules instead of 16 gig modules. So that means you can load up a 2-socket server with 768 gigs of RAM if you want to, and it's not going to break the bank like it did even 6 months ago. Memory prices have come down a lot lately. All right, PCIe. This is a slot in your motherboard that a modern 2-socket server probably has 6 or 7 of these, and a 4-socket might have 10 of them. And depending on how old your server is, you might be stuck way back here on PCIe version 1.0. And if that's the case, that entire slot, and this X4, X8, and X16, that means how many lanes, electrical lanes, are in the slot. And that means if you're on this worst case scenario of PCIe 1.0, X4, the entire slot can only do 750 megabytes per second. And so if you had a nice expensive Fusion I/O card in that slot, that card would be severely bottlenecked and throttled back by the slot because the card might do 4 or 5 gigabytes per second instead of 750 megabytes per second. And this also comes into play with high-end network cards and HBAs for SANs and RAID controllers, anything that needs a lot of throughput, you don't want to be on PCIe 1.0. So if you've got a server that might be 2 or 3 or 4 years old, you probably have this. But if you have a newer server, you're going to be down here, and that's where you want to be. And so far, only these Intel processors have PCIe 3.0 support. Anything from AMD is still stuck here, and older Intel processors are still stuck here. So this is really important to understand, because how much sequential throughput you have from these slots tells you how much output you can do for that entire server ultimately. All right, so key BIOS settings to pay attention to. There's something called Turbo Boost that we talked about, and AMD has something similar called Turbo Core. They should both be enabled. There's no reason not to have them turned on. Hyperthreading should be enabled most of the time. It just gives you more capacity for OLTP workloads. It can sometimes hurt performance for data warehouse workloads, but if you're in doubt, test it before you just turn it off. And then if you know you're going to have a virtualization host and you're going to be running nothing but SQL Server VMs on that host, I would probably disable hyperthreading on the host, so then all my virtual CPUs are true physical cores rather than logical cores, and you'll get more performance out of it if you do it that way. And then the other thing that's important is that the processor power management in the BIOS should be set to OS control or just disabled completely. And that way, if you do it that way, then the Windows power plan is in charge. And if you set that to high performance like you should, then you're going to get the best performance. And it's really important to use this tool called CPU-Z to see how fast your processor cores are actually running at. And the energy savings you get from power management is really expensive from a performance point of view. So you might save 50 or 100 watts per server by having power management enabled, but you give up 20 to 30% of your performance to get that. And that's just not worth it on a database server. It makes sense on a laptop to make your battery last longer, but it's not a good idea for a mission-critical database server. All right, there's something called the TPCE OLTP benchmark, and this replaced an older benchmark called TPCE, and this has been around since 2007, this particular benchmark. And there's an online, if you follow this link, there's an online database that shows you all the results that have come in for this. And the hardware vendors like Dell and IBM and Lenovo now, I should say, they will submit a system and go through all this testing and get it audited, and then they submit it and it goes into the official database. And there's been 74 of these as of December 17, 2015. And this benchmark is a really much more realistic benchmark than the old one. It doesn't require you to have hundreds of hard drives or flash storage like the old one did, and it actually requires fault tolerance instead of letting you use RAID 0. So it's a lot more realistic. It's got realistic data model and realistic data in it. And this benchmark is actually CPU bound if you have adequate I/O capacity. And so that means you can use it to compare CPU performance, one processor versus another one. And if you're really a total geek like I am, you can look at the executive summary and then this big thing called the full disclosure report for all the gory details of how the system was built and what parts it used and how it was configured. But if you don't want to look at all that, they have just a summary that's available you can read just in a few minutes. And when you're looking at these benchmark results, keep in mind that processors equal sockets and cores equal physical cores, and then threads equal logical cores. And so sometimes people get confused of what the differences of this is. So here's an example of how you would use this benchmark to do some analysis for sizing and consolidation purposes, for example. So these are some actual TPCE scores that I got from their database for particular model processors. And if you take the actual score, which is right here, 11,058, for example, and you divide it by the number of processors in the machine, so it's an 8-socket machine in this case, you get a score right here, 1382 per processor. That's sort of an indicator of the scalability of that processor as you go from 2 sockets to 4 sockets to 8 sockets. So here's the exact same processor in a 4-socket machine instead of an 8-socket machine. Then the score goes down, but it's not down by 50%. And if you do that division, you can see that this is actually quite a bit higher. So this shows you that as you go from 4 sockets to 8 sockets, you don't get double the capacity, because that's what this number really means. How much CPU capacity does this machine have? And so 2 4-socket machines would be better than 1 8-socket machine. And then here's another example of a 2-socket machine, and here's its raw score divided by 2 gives you this. So you can see that 2 of these would be better than 1 of these. And you could actually even do better than that if you wanted to, because the problem is when the hardware vendors do these benchmarks, they always pick the flagship processor with the highest core count. Excuse me. And we know now that you're better off for SQL Server by picking a lower core count processor that has a higher clock speed. So I could put together a system that would do even better than this. And then the other way you look at this with these numbers is take the actual score and divide it by the number of threads on the system. And that gives you an indicator of how fast the single-threaded performance is, which is really critical for OLTP performance, because remember, your query is running on 1 thread, and the faster your single-threaded performance is, the faster your query will be if you don't have any other bottlenecks. So we take these same numbers and divide it by the number of threads in the system, and you can see the score goes up as you go from this one to this one to this one. And again, I could do a lot better than this if I picked a lower core count processor like that 2667 V3 that I talked about earlier. That would have a much higher score here than this one did. So again, all of this shows that a lower socket count server performs better for single-threaded performance, and it proves that the scalability decreases as you add sockets. It doesn't go up in a linear fashion like you might expect. So just be aware that bigger is not faster, and you have a point of diminishing returns, and you can see that very clearly here. And this is another example using SQL Server 2012. They have some older benchmark results that were run on it, and when they were running these 2 or 3 years ago, the processors were older and had less capacity, so the scores were lower. So if we go back, we're talking about 11,000 versus 5,400. They've almost doubled the performance on an 8-socket machine. And so you can see the equivalent things that I calculated out here. And you can see the same story. As you go from 4 to 8, you lose performance in terms of scalability. And the same way for threads. You can see that the numbers go up as you go down this chart for the most part. And this is going to vary based on the exact processor that you choose. And that's another thing that's sort of useful but frustrating, is that, again, the hardware vendors only submit the highest core count systems when they do this, and that's not what we're going to pick. So you can go in, and I've written some blog posts and a couple of articles on SQLperformance.com that explain this in more detail, but you can go in and do some very simple adjustments with simple multiplication and division to adjust for the difference between an 8-core processor and an 18-core processor, and then adjust for the difference in the clock speed, and then have your own estimated TPCE score for a system with an 8-core versus an 18-core, for example. And I do that all the time for customers, and you can use that to convince yourself and the customer that, yeah, you can take your old 4-socket server and run it on a new 2-socket system and actually have plenty of capacity and have much, much better single-threaded performance. And that's what you want to do. You don't want to just guess. You want to go through and try to do some sort of calculations. All right, another thing that you might want to pay attention to that's very useful is another benchmark out there called Geekbench. And this is a cross-platform benchmark test that you can run on your phone. It also runs on Intel processors. You can run on your laptop. You can run on your database server. And all it does is test your CPU and memory performance. And it takes about 3 or 4 minutes to run. You can just Google Geekbench and go out and download it for free, or you can pay a small fee and get the 64-bit version, and I encourage you to do that. And there's no configuration required. You just click a button and wait a couple minutes. And this benchmark correlates pretty well with TPCE scores. And I use this benchmark to help what I call adjust TPCE scores and when I have different CPUs. So if I need to compare somebody's existing system with a CPU that's not in the TPCE benchmark database, I can use Geekbench to help me sort of come up with a good estimate for what this different processor would do. And there's an online database of Geekbench scores. So you could run this on your own server, not when it's in production, but you could also run it on your laptop. And then you can look in the database and find other ones to compare it to. So if you're trying to make the case to your boss that it's time to do a database server upgrade, and you can go and look in the database and find the score for your system, and then find the score hopefully for the new system you're trying to get, that can be really, really useful. And this next slide shows you a chart of some different Geekbench scores. So back when I worked at NewsGator, we ran all of newsgator.com on a Xeon 7140 in a 4-socket server, okay? And that server back then in 2007, 2008, that thing cost $30,000 for this one server, and it had this processor, which is the fastest you could get back then, and its Geekbench score was only 5282. Well, I've got a little laptop sitting next to me that weighs 3 pounds, and it's not even a new laptop. It's about 3 years old now, and it's got a 6500 Geekbench score. So my little 3-pound laptop has more CPU capacity than this 4-socket server from, a number of years ago. And as you go to newer generations of processors, you can see these Geekbench scores really jumping. And something that I've done several times in the past with very effective results is I would be in a meeting and we're talking about upgrading the database server, and you're getting resistance from management. Oh, we don't want to do that. We don't have the money this quarter, whatever the reason is. And so then you run Geekbench on your laptop, and you Geekbench on your production database server during a maintenance window. And then you show them that your laptop has more capacity than your production database server. And usually that blows their minds. They think you're kidding. But when you show them that, then that's a good piece of evidence for, okay, maybe it's time to get a new database server, rather than just complaining about it and not having any numbers to hang your hat on. It's a really useful technique. Now, just to review what I've talked about tonight, don't make the mistake and don't let anybody ever talk you into reusing old hardware for a new database server. Because not only you're going to give up all sorts of performance, if you do that, you're much more likely to do what's called upgrading in place. And upgrading in place is fully supported by Microsoft, and people do it all the time, but it's really a bad idea, and it's very, very risky in my opinion. So upgrading in place means that, okay, we're going to move from, say, SQL Server 2008 to SQL Server 2014, and we're going to upgrade in place on our current hardware. So that means you're going to come in early Saturday morning and install SQL Server 2014 on your existing server and pray that everything works. And of course, if you're smart, you backed up all your databases and you've got a plan for how to recover if it doesn't work. But you do this, and then it's going to take, maybe an hour or two to get it installed and patched, and you're down while this is going on. And then you're just hoping everything works, and that's really, really risky. And what you want to do instead is you make the case for we need a new server with a new OS and a new version of SQL, and you build that and get it all cabled and racked and everything installed and patched and configured, and then you take backups of your databases and restore them on this new environment and test it to death for weeks or months if you need to, until you're completely confident that everything works. And then you do some way with database mirroring or log shipping of doing a production failover, and you're just down for 30 seconds to go from the old environment to the new environment, and you're absolutely confident that everything's going to work because you were testing it for weeks, you and the QA department and everybody else. That's a much, much better way to upgrade instead of upgrading in place on the existing hardware just because your boss was too cheap to buy new hardware that was faster than the old hardware and still under warranty, for example. So the next thing to keep in mind is that always consider your workload as you select your hardware. So if you know you have an OLTP workload, you're going to be biased towards a certain kind of processor and certain kind of storage and the way you configure everything versus a reporting or a data warehouse workload that's going to have different requirements. So make sure you understand that, and you should understand that better than the person in your IT department who's more used to buying file servers and web servers. You know, database servers are different, and the workloads on them can be completely different, whether it's OLTP or OLAP or data warehouse. And then, after you've done all that, keep in mind those expensive SQL Server license costs, and try to pick the lowest core count processor you can, which is going to have faster clock speed, and that will minimize your license costs, and your queries will run faster, so your users will be happier because you were smart about this instead of letting somebody who didn't know what they were doing make that choice. And then it's really important that you pick the most appropriate Intel processor for your workload. And the details matter, you know, so even if you don't care about hardware, read my blog and I'll tell you exactly what processor to pick. But you know, it's important that you pay attention to this, because if somebody makes the wrong choice, you're going to be stuck with it for probably 2 or 3 or 4 years. And then get as much RAM as possible. RAM is very inexpensive. I mean, one thing I did at a couple jobs is I was lobbying to get some more memory, and I was getting pushback from management. So then I said, well, okay, well, I really am convinced that we need more memory in this system. And if you guys won't buy it, I'll buy some memory myself with my credit card. And whenever I did that, they always were embarrassed and they backed down and bought the memory. But my point is that memory is so inexpensive that if they called your bluff and said, okay, go ahead, well, you could buy some memory and you wouldn't have to mortgage your house to do it. You know, memory is about, you know, $8 a gigabyte. And then finally, I didn't have time in this presentation to talk about the I/O subsystem, but don't neglect that. I see so many DBAs and so many IT people, they go out and buy a nice server with nice processors and lots of RAM, and then they try to run a really intense workload on 8 hard drives, for example. Completely inadequate. You know, it depends on your workload, but no, don't neglect the I/O subsystem. That's something I see all the time. Now, I've got some good hardware references here. So I've got links to where you can go and download Geekbench and look at the TPCE OLTP benchmark and get that CPU Z tool. And then another thing that's really handy is something called the Intel Arc database. And that gives you all the gory details on every single Intel processor. So once you know the model number, you can just Google that and it'll take you right to the Intel Arc database and it shows you all the specifications for that processor. And then AnandTech IT has a lot of good articles about processors and storage and stuff from an IT perspective. And then finally, Storage Review is a really good website that has lots of tests and information about storage subsystems. And something I want to show you before I take questions is there's a tool that I've mentioned several times. It's right here. It's called CPU-Z. And this tool lets you identify your processor, and it lets you see how fast the clock is running, and it changes from second to second when it's under some load. And so this is a really handy tool to figure out what's going on with your power management and what kind of processor you have and how many cores it has. And then something they have in the latest version of this is a little benchmark tool. And if you go to this benchmark tab and then click on the bench CPU button, it goes through and just in a couple minutes it does a really quick and dirty CPU benchmark for single-threaded performance and then for multi-threaded performance. And what I'm asking people to do, I wrote a blog post about this a couple days ago. I'm asking people, go read my blog post and then run this test and take a screenshot of this tab right here showing the scores, and then another screenshot of this tab showing what kind of processor it is, and just send it to me in an email, glenn@sqlskills.com. And I'm putting this stuff into a database because I'm working on a project that I'm going to unveil to the public fairly soon, where I want to have something that lets you use a tool that helps you compare processors. And so, this is just another piece of information that tool is going to use. So the more results I can get from different processors are really useful to me. So this would just take you, 5 minutes to do if you have some spare time, and run this on a laptop or any other kind of machine that you want to. So with that, I've got some time, I think, for some questions if we have any.
Yes, we got a couple of questions. I'm gonna unmute this. This person. If you would like to ask your question directly, I have unmute you. Okay. Well, I guess the question is like, can you advise why do we need soft NUMA? And then in why do we need soft NUMA?
Okay. Well, soft NUMA is something that's been around for a while, and it's a way at the OS level and the SQL Server level to divide your actual physical NUMA nodes into smaller NUMA nodes. And to be honest, I haven't seen very many workloads where that was really necessary, but I think in some cases when you have lots of cores on a high core count processor, having a single large NUMA node doesn't work quite as well as the theory behind it. But I just haven't seen that many workloads where it really was necessary. But it's something that's going to be a new configuration option in SQL Server 2016. They're going to make it a little bit easier to work with than it was in the past. But yeah, that's my understanding of why we might need soft NUMA, but I don't see too many people who actually do need it.
Okay, so the next one is, in what situation do we need to configure soft NUMA for SQL Server?
Okay, well, I mean, that's kind of related to what I just said. The situation where you might need to do it is, again, if you have a really high core count processor and you're running into certain kinds of bottlenecks, and I'm not sure how you would actually identify that, but that's something I could look into. If somebody really wants to know the answer to this, I can look into it and probably get back to you. So send me an email, Glenn@SQLskills, and I can try to get to the bottom of that, how you might detect that you might want to turn on soft NUMA.
Okay. The third one is the L3, L2 cache. The perfect is per socket or per core?
Okay, well, with modern Intel processors, each core has its own L2 cache, and then an L3 cache is shared across the entire processor, so all the cores share it. And one thing you'll notice if you look at the processor specifications is that the lower core count processors typically have a smaller L3 cache, and as the core count gets bigger, it gets larger. But in some cases, there'll be a jump. So for example, with the Haswell EP, the 6 core has a 25 meg, and the 8 core also has a 25 meg L3 cache. So because of that, the 6 core actually has more L3 cache per core than the 8 core does. So that's another reason why the 6 core is really, really fast.
Okay, Craig, if you would like to ask a question yourself, I haven't muted you. Okay. Would you like to ask the question yourself, Craig?
Yeah, this is Peter Lu. Understand nowadays people host the database in the cloud. Like one of the options is hosting in Azure. So what is the size considerations when you host your server host your database in Microsoft Azure?
Well, there's two different versions of Azure. There's Azure SQL Database, which is a little bit different from traditional SQL Server, where it's a platform as a service. And in that case, the hardware and all the other stuff is completely abstracted from you, and you just go and create databases, and you can pick the size of the databases and the performance requirements. So I'm not going to really address that much. But the other way that people do it is you can have Azure VMs, and you can pick different size VMs, and you have regular SQL Server installed there that you have to maintain, just like an on-premises SQL Server. So in that case, it would be, in my mind, very similar to on-premises SQL Server. You have different sizes of VMs you can pick with different numbers of cores and different amounts of memory and different levels of storage performance that you can pick. So you would go through the same kinds of exercises to try to figure out how much you need, and you would pick a VM that was that size. And the nice thing about a VM is that you can change the size of the VM if you mess it up and you need to go to a larger VM. Of course, it'll cost more money to do that. So.
Just to follow up with one more small questions. There's one database host, one database server host. What is the threshold to switch from the first to the second when it comes to the performance and load?
Well, I'm not quite sure I understand your question there. I mean, it depends on your workload, and if you're running an Azure VM with SQL Server running in it, you can run all your regular performance monitor metrics, and you can run some of my DMV queries, for example, from my diagnostic query set, to understand how hard the VM is working. What is your average processor utilization? Are you under memory pressure? Are you seeing high I/O latency? So you can use all these existing tools to judge, okay, this VM is running pretty much at capacity, so I can either tune my workload, tune my queries, and do index tuning to relieve that, or I could just move to a larger VM with more capacity. And that's the same way as an on-premises. You have to go through that kind of exercise. But I can't just throw out a threshold. It depends. I don't want to be running at more than about 60 or 70% CPU, for example. And I don't want to be under any memory pressure. And I don't want to have really high I/O latency. And that's, to be honest, the biggest weakness of running a cloud right now is that they just don't have as much I/O performance available as you can get with on-premises. But they're improving that all the time. They're getting better, but that's their big weak point right now.
Thank you.
Okay. Any other question?
Yeah, one more. I don't know how to pronounce his name. So the question is there a point at which Azure would make sense when it comes to CPU counts, keeping costs versus performance in mind?
Well, I mean, again, it depends if you're talking about Azure SQL Database, which is platform as a service, versus Azure in a VM, which is infrastructure as a service. But you would just have to run the numbers. I mean, Microsoft keeps changing the price of Azure. They have competition from Amazon, for example. So typically they're lowering their prices and improving their performance. And so you have to look at that versus how much it would cost you to go out and get your own hardware and get the licenses and then the staff to maintain your own stuff. And so it's going to be different for everybody. But more and more workloads can run in Azure. There's no doubt about that. But some people just aren't going to run their stuff in Azure because maybe they're worried about the sensitivity of it or the fact that Azure occasionally will go down. And if it goes down for a while, they might give you a credit on your bill, but you have no control about when it comes back up. Versus if it's your own on-premises, if you go down, then your CEO can yell and scream and threaten people, and maybe you come up more quickly, but at least it's in your control. So there's lots of things you have to consider if you're thinking about going to Azure, but Azure is getting more reliable and getting more affordable, so in the future I think more stuff's going to run up in Azure.
Hi Glenn, sorry for interrupting. This is Jayant here. I basically asked a question. The reason I'm asking about Azure is basically in SQL 2016 as well as new versions, we're seeing more integration with big data kind of scenarios where we're using kind of like commodity hardware to kind of throttle CPU usage. So the question is mostly around like for very large volumes of data, we are seeing scenarios where the cloud actually does a very significant volume of data processing at a much lower cost compared to on-premise systems. So typically, you process 10 terabytes of data on the cloud, and only the aggregated final results come on-premise. So is that actually a good approach, or would you recommend to do all the processing in-house?
Well, I mean, it depends. I know there's lots of hybrid scenarios, and Microsoft is pushing that on people. And there's a new feature in SQL Server 2016 called Stretch Database, for example, that lets you take a table and move part of it up into the cloud. And that's just an example of some hybrid functionality that's going to be built into the product. I'm not convinced how well that feature is going to work in the first version, but Microsoft has a whole panoply of offerings where they want to try to have you put some of your stuff in the cloud, but if you don't want to have it all up in there, there's ways of sort of having on-premises talk to the cloud and do some of your processing up there. So I think that's a perfectly valid thing to do. You just have to look at your situation and run the numbers and decide if it makes sense for you or not from an economic point of view. But technically, there's no reason not to do that, I think, with all the increases in performance they have now.
Thanks, Glenn. Just one more question. When it comes to hardware virtualization, we obviously have a number of different softwares out there. So based on your experience, is there any particular software that performs better compared to the rest? I mean, like we got, VMware and Hyper-V, etc. But for the same configuration, is there any advantages for one particular version over another?
Well, I don't think there's any real measurable performance difference between Hyper-V and VMware. I know Hyper-V, has less of a market share than VMware, and fewer people are familiar with Hyper-V, but then Hyper-V comes for free with Windows, excuse me, as opposed to paying extra for VMware, but a lot of IT people are more familiar with VMware and they just like it better. But performance-wise, there's not a huge difference.
Thanks.
Is there any questions? If you guys would like to ask questions, please raise your hand so I can unmute you.
One thing I'll say is, again, if you want a free Pluralsight code, send an email to Paul and make him do some work.
Okay. I have a good question. There was one time I tried to publish my SSRS report to the report server, and then I just kept getting error. So I had to wait like after 3 some hours and finally publish the report. And I had asked our DBA, and I guess their answer is like, they need more memory. I was wondering if this is really related to hardware for not being able to publish report.
That doesn't sound too likely. Being under memory pressure for an SSRS server would just affect the performance of it, but I can't believe that would prevent you from being able to publish a new report. But I'm not an SSRS expert by any means.
Okay, cool. Thank you so much, Glenn. This is a great session, and we really appreciate you taking the time and share the hardware knowledge with us. So thank everybody for coming in to join us. And if you have questions, comments, or suggestions, please email us at SQL at sqlpass.org. Glenn, if we have more questions, do you mind if I forward it to you?
No, not at all. And again, Glenn at SQLskills.com is my email, so either you can forward questions or people can just send them directly to me. And I'm going to have a PDF version of the deck that I'll send you that you can put up with the recording if you want to.
Sure, that'd be great. Thank you so much.
Okay, well, thanks everybody for listening. I appreciate it.
Thank you. I guess this meeting is adjourned. I hope to see you guys at our next meeting on in February.
Okay, well, thanks a lot.
Thank you. Goodbye.